guys and gals, let's check out parabolas. We've talked about parabolas in the past, but we've talked about the function. This time, it doesn't have to be a function. So it is a conic section. If we cut the cone perpendicular to the base, it will form a parabola. Parabola is a set of points such that each point is equidistant from a fixed point called the focus and the line called the directrix. So this is the focus, this is the directrix. These distances will always be the same. So that is d1 equals d2 here. Okay. So we could have a vertical parabola, or we could have a horizontal parabola. Realize that this is not a function, but we're still going to, deal with it just as we would a vertical one. It could open up or down. This one could open right, or it could open left. What decides that is the p-value. So, focus is always inside the parabola, directrix is outside. Directrix and the axis of symmetry are always perpendicular, and the vertex is absolute value of p units away from the focus and the directrix. So again, here's the vertex, focus, directrix, vertex, focus, directrix. So I would just say it's p units away, plus or minus, depends on which way you're going. Here's our standard forms. This is for a vertical parabola. This is a horizontal parabola. Look at what's being squared. If x is squared, it's vertical. If y is squared, it is horizontal. And again, p being positive or negative will tell you which way it's opening. So put it in standard form. You probably have some completing the squares to do. Just same thing we've been doing. Start with the center. Center? You mean vertex? Okay, that should say vertex. Vertex. And solve for p. Pretty much count. Well, we're going to count after we find p to find the focus and the directrix. And we're going to sketch the thing. So let's just get started. Number one, x is being squared, so if we look at it, it's going to be a vertical parabola. So let's just compare this equation. Alright. There it is. So here's my equation. HK, that's easy enough. That's 0, 0, right? That's my vertex. Right there. Okay, well, axis of symmetry, since it's going to be vertical, is going to be x equals the x coordinate of my vertex. That's the same. It would be y equals the y coordinate if it was a horizontal parabola. Now the focus and directrix, we need to find out what p is. So we know that this is the form that the equation takes. Right here we have -8. So -8 has to equal, let's look at it right here, 4p. So that tells us p is equal to -2. So for my focus, I'm going to go 2 units below my vertex. It's opening down because p is negative. My focus is inside. So if it's a -2, then you go down 2. If it's positive 2, you can go up 2. Or right, left, depending on which way it's pointing. We know this one's vertical. P is -2, so we go down 2. That gives us our focus because that's negative. We go up 2. The line going through this point will be our directrix. Let me graph that real quick. So this is our directrix here. Now, we don't have any points on the parabola yet. We need to figure out some points. Well, one thing, I'm going to graph this in Desmos, and you can see where the points need to be. One particular thing we could do is make this be a nice number. So if this were equal to p, then that would be 4p squared, and we can square root that, right? So let's see what needs to happen to make this equal to p. Let's see what we need to plug in for y. So y minus k equal to p. That's what we need to happen. We need this to become p. That way this would be 4p squared, and we can square root that. So that means y equals k plus p. And yeah, it's going to be plus or minus, depending on which way we're going. But we're just going to get 1 point right now, okay? We can use our axis of symmetry to reflect it later. Let me do that. So this is my y coordinate, okay? This is the y. This is for a vertical one, by the way, vertical. Now what happens if we do that? Well, this becomes 4p squared. This is x minus h still, squared. So we're just going to square root that. And if we do that, we get x minus h is equal to 2p. So x equals h plus 2p. So that's a lot to figure out, but guess what? You don't have to figure it out. Let's look right here. What's h? Well, h and k are both 0, 0, right? So we're going to go, the y value is going to be p units, the x value is going to be 2p units. Well, if we go p units away, that is right there at our vertex, our focus. So we go p units away from our vertex, that's the focus. And then if we double that, 1, 2, 3, 4, this should be a point. 1, 2, 3, 4. And this should be a point on the parabola. Let's go check it out on Desmos. So here I have it graphed already for us. And if we look, sure enough, we have the point -4, -2, -4, -2, and 4, -2, 4, -2. So those are 2 points on our parabola. So we can manipulate the numbers and get a few more nice points. There's those guys we just calculated. And then we could also do -8, -8. That's also some nice points on this particular parabola. Well, what happened there? If this were, instead of p, if this were, let's say, 4p or 9p or p cubed even, we get another nice point. So right here, we just move it along when, there we go, almost, there we go, -8, -8. So if we look at that, if this were 1, we plug in 1 right here, x is -8, well, if this were -8, then -8 times -8, that's 64, right? Square root of 64 is 8 plus or minus, so that's -8, -8. So we just have to make this number right here be a perfect square. And that's what we did. An easy way to do that every single time. From your focus, go left, right, up, or down, depending on if it's vertical or horizontal, 2p units. And that'll always get you some points on there. And you know what? We're going to say that's enough points. We're just going to graph the dang thing. Could you go more points? Sure you could. We know it's going to be -8, -8. So we know it's going to be down here somewhere. So we could sketch it better. But as long as you got these 2 points, we'll call it a day. So just sketch it, something like that. And I'm not an artist. You're not an artist. Just try and make it kind of curvish. Make it look parabola-like. And we're good. So if we examine this graph, anywhere on here should be the same distance from the directrix to the focus. So these distances should always be the same. So if we chose some nicer numbers, we might be able to calculate it. But just look right here. These distances have to be the same to make up the parabola. To make an easy point, just go 2p units from your focus. Okay, it's that simple. Now we never actually wrote down what the focus was, so let's write that down. It's 0, -2. And the directrix is the equation. It's y equals 2. 0, 2. Yeah, 2. Right there. Axis of symmetry and directrix are always going to be perpendicular. Okay, let's keep going. Now this time, let's look. This had x squared. This one's y squared. So this one's going to be a horizontal parabola. So let's get this equation. Again, the process is going to be very much the same. Doesn't matter if you have horizontal or vertical, steps remain the same. Figure out h and k. So this time it's h is 0, k is 0. So our vertex is 0, 0. I'm going to plot that. And this time our axis of symmetry, since we're horizontal, is going to be y equals the y coordinate of the vertex. So this right here, the x-axis, is going to be our axis of symmetry. Again, we need to calculate what p is. So 6 equals 4p. We get 3/2. Not exactly the nicest number, but we can use it. Since we're horizontal, I'm going to count on the x-axis 1.5, 1.5. P is positive, that means it's opening to the right. So it's something like this. Alright. If I multiply that by 2, I get 3. So if I count 3 units here, 3 units there, that should be my parabola. Let's check it out. Again, we can sketch our directrix, I guess. Right there through the middle. And this should be our graph. Let's do a nice orange color. I always have to start at the vertex. I'm terrible at drawing. Oops. Something like that-ish. We're just going to sketch these graphs. We don't have to be perfect. But let's type this in. Y squared equals 6x. So let me get rid of all this. Y squared equals 6x. So our vertex is 0, 0, so we should have 1.5 and then 3. So right here, this should be at 1.5. There it is. So that is a nice point on our parabola. It's not the nicest point. I mean, it would be nice if it was an integer, right? Let's see if we can visually see anymore. How about this point? Yep, 6, -6. So once we actually have it graphed, we can see where those points should be. And that'll also always work. If whatever this is if you go from the vertex that many units, that'll multiply together to get you that. That was too many that's. So if we make the x minus h part equal to whatever that is, it'll be a perfect square, right? So then that would also be another point you could use. Where were we? Focus. So that's at 1.5, 0. directrix, that would be at x equals -3/2. Okay? So like for this one, if we make this equal a 4, that would be 16, and we could have a nice number there. We'll see what happens whenever we plug in 2p. Well, not plug it in, but plot it. Okay. This time, we have another horizontal parabola. So we're going to use that formula again. So h and k, 3, 2. Make sure you pay attention to the order. It's the x, then the y. Vertex is going to be at 3, 2. Right there. Excuse me. Axis of symmetry, since it's horizontal, will be y equals 2. Y equals the y coordinate. The focus. For that, we need to figure out what p is. So, -4 equals 4p. -1 is equal to p. So it's going to open to the left. Okay, this one's got a negative p value, so that's going to open to the left. One unit in gets me my focus. 1 unit out, that's what my directrix is going through. That was a little off. Let me see if I can move it a bit. Make that dotted, and there we go. Directrix, focus. I guess we can write down their coordinates while we're at it. 2, 2 for the focus. X equals 4 for my directrix. From my focus, I'm going to go 2 points. Now, it's got to look like this. I'm going to go up 2. I'm going to go down 2. And this should be a nice parabola once we graph it. I'm just doing worse and worse. Yeah, just sketch the best you can. I'm not going to take off too many points for that. Don't make it an absolute value, though. Don't make it a pointy butt. And yeah, if we look, we go 2 units here, we go 2 units there. There we go. We got a nice, lovely parabola going on. I think that's it for that one. Let's check this one out. This time we have a vertical parabola. It's going to be -1, -2 for our vertex. That comes directly from here and here. 14 is equal to 4p. 7/2 is p. It's another not so nice one. It's about 3.5. Well, it is 3.5. Plot my vertex, -1, -2. Now, let's see, we said it was vertical. It's opening up. Something like this. So I'm going to go 3.5 units up. I'm going to go 3.5 units down. Below it's going to be my directrix because p is positive. Okay. Directrix. And right here is my focus. So let's get those ordered pairs. Axis is symmetry. It's vertical, so x equals x coordinate. Directrix. Y equals 1, 2, 3, 4, 5. We could say 5.5, which is 11/2. Focus is at -1, 1.5, or -1, 3/2. All right. let's see. Here's my focus. If I double P, that's 7 units. So I'm going to count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. So if we sketch our parabola, it should go through these points. Make it a little thinner. Terrible. All right, one more try. Yeah. Obviously, I suck at graphing. That's less terrible. But whatever, we got it. That should be the whole dang thing. Why don't we go ahead and check it on Desmos? Let's see if we are getting the right points at least. I mean, we should get 1, 2, 3, 4, 5, 6, 1.5 on there. If we don't, we definitely did something wrong. So let's just sketch it. X plus 1 squared equals 14. Y plus 2. And where did we say? We said at 6, 1.5. So 6, it should be 1.5. Oh, there we go. Beautiful. Perfect. Lands right on it. Of course, we could do, 14 squared here, but that's a little far off. So we'll call it that to be it on this one. Okay, let's look at the difference. Here we had just a regular y squared and x squared. On this one, we got a coefficient on that x squared. It's an x squared, so that's what's important. So it's another horizontal one. I guess I don't need the formula. But we got to fix it. We had to put it in standard form. I do need a formula. So we need to make sure it looks like this. All right, so we have x minus h. Well, h is 0, y minus k, k is 0, so that's easy enough. 0, 0. And then our axis of symmetry is just going to be, let's see, it's vertical, so x equals x coordinate. Our focus, we need to calculate p. Do you notice something interesting? This has a coefficient here, so it's not in standard form yet. We have to multiply both sides by 4. So x squared equals 4y. All right, so p is going to equal, 4p equals 4, 1. I'm sorry. X is being squared, so it's going to be vertical. P is positive, so we're going to go right here for my focus, down here for my directrix. Okay, plot that on the x-axis, or on the y-axis right there. We're going to plot our axis of symmetry. And there we go. Points. Here's my focus. I'm going to count 2p units on either side. Come on. And then we're just going to sketch the thing without being so terrible. All right, good enough for me. Let's see what they've thrown at us next. I'm completing the squares. Nope, not yet. Okay, so on this one, we have to move everything over to this side because look at our standard form. Grab that. All right, so let's rearrange this a little bit. So that's going to be add 3 to both sides. That's going to equal x plus 3, right? Now, I need to take this negative 1/10 and multiply both sides by negative 10. That way it'll cancel here. Y plus 2 squared. Now it's in standard form. So we can see our vertex is -3, -2. Plot it. And then let's figure out what p is. -10 equals 4p. -5 over 2 is equal to p. So it's negative, so it's going to open left because we're horizontal here. Oop, we're horizontal. Oh, I did it right. Okay, sorry. I thought I messed up my h and my k for a second. Triple check, make sure we didn't. H is -3, k is -2. Okay, good. So from my vertex, I'm going to go left and right because we're doing a horizontal parabola. And for my focus, I'm going to go left 5.5 units. So that's 2.5. 5 halves unit, I don't know what I said. I said 5.5, that's not the same. All right, sketch that directrix. All right. From my focus, I'm at double P, so luckily that's a 2, double 2, I get -5 and 5. 1, 2, 3, 4, 5. 2, 3, 4, and 5. Sketch that the best I can. Oof. And there we go. We'll try a couple more, but it's not too terrible. Complete the squares. So what's the quadratic part here? The y. So this is going to be horizontal. So I need to complete the squares with the y. I need to get all the other stuff to the other side. That's what I'm going to do. First I'm going to rearrange it. Y squared minus 2y something equals 16x plus 30 minus 33. Cut that in half and square it. That's going to be 1. I'm going to add that to the other side. And then b over 2, so I got to factor this. Y minus 1 squared equals 16x minus 32. Factor out your GCF here. Well, factor out the coefficient of x because it has to be factored out. Doesn't matter if it's nice or not. It should be. I completely forgot my x. Wow. And that's going to be x minus 2. Yeah. This is going to be y minus 1 squared. Now that it's in standard form, we can use our equation. find out what P is. Wow, okay, yeah. Daydreaming there for a second. P is 4. Get some coffee. So let's plot this stuff. Vertex 2, 1. Axis of symmetry, since it's going to be horizontal, it's going to be y equals the y coordinate. Focus, go 4 units, let's see, this way and that. Okay. It's opening to the right because P is positive. It's going to do something like this. This is my directrix. I'm going to just do this. I think it's quicker the other way even, but we got that now. Where were we? So, double the P, we get 8. So 1, 2, 3, 4, 5, 6, 7, 8. And 8. Except these need to be a little bit over here because I was counting from the vertex, but I meant to count from the focus. Sorry. So now we can sketch our parabola. And I missed. And there we go. Focus was at 1, 2, 3, 4, 5, 2. And that's at 1, 2, 3. X equals -3. So x equals, that's going to be -3. Yeah. Last one. All right, we're going to complete the square again. I'm going to move my y and constant over the right side. X squared plus 10x. Divide that by 2 is 5. Squared is 25. I want everything else on the right side. So that's -4y minus 1 and plus 25. Okay. Factor this, x plus 5 squared equals -4. That's going to be -24 here, right? If we combine like terms. So factor that out. Y minus or plus 6. Okay, factor out a -4 from here. We get y plus 6. So x coordinate is -5. Y coordinate is -6. All right, that is my vertex. Axis of symmetry, x equals, let's see, this one's vertical, so x coordinate, -5, that's how I knew it was x equals. Focus, it's going to be p units, so let's figure out p, -1, right? Should be able to figure that out just by looking. So that means this one's opening down. I'm going to double that. Oops. And sketch the graph. Arg. And there we go, good enough. This is the directrix. Focus was at -5, -5, -7. And the directrix, -5, -5. And that's it. Yeah. So that's how we graph parabolas, ladies and gents. Again, if we manipulate this formula enough, we could find all kind of different nice points. But as long as we have a couple points to go through, we're just sketching these things. Good enough. All right, I'll see you next time. Goodbye.